Earth's magnetic field has decreased by 9%. In another 1,600 years, it will reach zero. Recently, scientists using the European Space Agency's swarm satellites observed that over the past 200 years, global magnetic field strength has decreased by an average of 9%. If this continues, Earth will lose its magnetic field, transforming from a blue planet into a dusty yellow planet like Mars. Although we cannot yet drill to Earth's core, scientists believe Earth's magnetic field is generated by the flow of liquid iron in the core, like a giant generator, driving magnetic field lines from South Pole to North Pole. This magnetic shield blocks solar wind. Without it, high-energy charged particles from the sun would peel away Earth's atmosphere, layer by layer like an onion. Over the past 200 years, magnetic field strength has declined by 9%. Especially in the South Atlantic anomaly where the decline is more pronounced. This region stretching from Africa to South America has a magnetic field 30% weaker than elsewhere. Satellites are often disrupted when passing through. Scientists estimate magnetic field strength decreases by about 5% to 6% per century. If this continues, it could approach zero in 1,600 years. Data from numerous Mars rovers and probes all show that Mars 4 billion years ago was a wet world, with rivers and lakes, and possibly even life. It also had a global magnetic field then, comparable in strength to Earth's, protecting its atmosphere and oceans, and any possible life. But later, possibly because Mars was too small, its core cooled too quickly, causing the liquid iron to stop flowing, and the magnetic field disappeared. Then Mars' atmosphere was stripped away. Over 90% of its ocean water evaporated, turning the planet into today's red desert. But Earth and Mars face very different situations. A 9% decline sounds significant, but on geological timescales, this isn't abnormal, because Earth's magnetic field is never stable. Its strength constantly fluctuates. Over the past 7,000 years, the magnetic field's average strength is similar to now, even twice the million-year average. Paleomagnetic studies show the magnetic field reverses approximately every 250,000 years, known as magnetic pole reversal. During this process, strength briefly drops very low. As for the South Atlantic anomaly's expansion and magnetic North Pole's rapid movement, such local weakening doesn't indicate a global crisis. The prediction of zero magnetic field in 1,600 years is just linear extrapolation. In reality, the decline could stall or reverse. Mars lost its magnetic field because its core cooled and the dynamo stopped. Earth's diameter is 12,700 kilometers, with the core occupying 32% of its volume. The liquid outer core is 2,200 kilometers thick, much larger than Mars. Plus, Earth's core temperature exceeds 5,000 degrees Celsius, maintained by radioactive decay and primordial heat driving convection. So scientists estimate Earth's dynamo can operate for billions more years, at least for another billion years. Even if the magnetic field briefly weakens to zero, Earth's atmospheric density and gravity far exceed Mars, able to retain most gases. It won't immediately become Mars-like. Within the next few centuries, we will also terraform Mars. But the primary task is first restoring Mars' magnetic field. Otherwise, even if we melt Mars' polar ice caps and recreate oceans, this liquid water cannot exist long-term on Mars. So, the first step in Mars development will likely be building underground spaces on Mars to avoid surface radiation and dust storms.